Today we are going to talk about Earth's changing atmosphere. You may need to pause this PowerPoint to fill in the blanks of your notes packet. Atmosphere is the layer of air that surrounds Earth and supports life and protects it. Altitude is the distance above sea level. Another word for altitude would be height or elevation. Density is the amount of mass in a given volume of a substance. Density decreases as you travel upward in the atmosphere, so the higher you go, the less dense the air is. The materials that make up the atmosphere include dust, sea salt, water droplets are suspended in the atmosphere. Nitrogen makes up 78%. Oxygen makes up 21% of the atmosphere. And argon, carbon dioxide, water vapor, and other gases make up 1%. And this is a pie chart just to show you the relationship between nitrogen, oxygen, and the other gases that make up the atmosphere. As you can see, nitrogen makes up the majority of the atmosphere compared to oxygen. Carbon cycle. This is where carbon dioxide and oxygen constantly circulates between animals and plants. So, animals, they breathe in oxygen and release carbon dioxide, and plants take in and absorb the carbon dioxide that we breathe out, and animals, and they turn it into oxygen through the process of photosynthesis. And again, it's just a cycle. Nitrogen cycle. This is where tiny organisms remove nitrogen from the air and transforms it into other chemicals that enter the soil. Plants and animals use it, and it is returned back to the soil when they die and decay. Soil releases the nitrogen back into the air slowly. Water cycle. Plants release water vapor from their leaves. Liquid water falls from the atmosphere as rain. Liquid water from oceans and lakes changes into gas and enters the atmosphere. So, the sun's energy starts to evaporate the water molecules, the water particles, the water droplets from the ocean, from lakes, from rivers, from streams, and it turns it into from the liquid to a gas called water vapor. As that water vapor rises up into the atmosphere, it cools and condenses. Whenever it cools and condenses, it forms what? If you said clouds, you are correct. It forms clouds. And once those clouds hold as much water vapor as much as possible that it can possibly hold, then it begins to precipitate. Does precipitation always mean rain? No. It could mean rain, it could mean drizzle, snow, sleet, hail. And then the precipitation falls to the Earth's surface. Some of it is absorbed as far as in groundwater, and some of it runs off to the other lakes and rivers and streams and oceans. Energy transfer. Sunlight is reflected whenever it hits a light-colored surface, and it is absorbed when it hits a dark-colored surface. So, let's say during the summertime, you go to Walmart, and the parking lot, whenever you get out of the car, the parking lot is really warm. Okay? Well, think about what color the parking lot is. Yeah, it's black. It's a very dark surface. So the sun's energy is going to be absorbed and it's going to be even hotter. Whereas, think about for some of you sports players. Don't you usually wear a light colored shirt, such as maybe a white or a beige shirt? Well, if you do, then it's going to reflect the sunlight back to the atmosphere. where it's not going to absorb as much. So it's going to cool you off. Radiation is the energy that travels across distances in form of certain types of waves. For example, sunlight warms the ground. So sunlight, it warms the ground, and the ground warms the air. Sunlight does not warm the air, okay? Sunlight heats up the ground. The sun's energy heats up the ground, and the ground warms the air that's directly above the ground. Conduction is the transfer of heat energy from one substance to another by direct contact. Example, warm ground heats the air. So, let's say you're cooking and you touch a burner because you're not sure if it's on or not. Well, whenever you touch that burner and you figure out that it's hot, well, that is direct contact. That is an example of conduction. Convection is the transfer of energy from place to place by the motion of gas or a liquid. For example, warm air carries energy upward. So an example of convection would be if you were to put a pot of water on the stove to boil. Well, the water at the bottom of the pot is going to heat up first because it's coming in contact with the heat source. So as that water starts to warm and it gets hotter, well, remember, warm air rises. So that warm air is going to rise to the top of that pot. So that warm water is going to rise to the top of that pot, and whenever it does, it's going to circulate the cold air, or the cold water in this case, to the bottom of the pot for it to be warmed. Well, that cold water that's traveled to the bottom of the pot heats up. Well, whenever it heats up, it's going to rise as well. So it's going to start to circulate. That's why the water starts to boil and you've got the bubbles, because that is convection. And this is just a diagram to show you the different types of heat transfer, such as convection and radiation, conduction. Air temperatures. Warm air. These are the characteristics that describe warm air. It rises, it's faster, and it's less dense. Cool air. It falls, it's slower, and it's more dense. And this is a diagram just to show you that warm air, it rises, and cool air falls. Warm air is lighter, so it's going to rise. And cool air is heavier, so it's going to fall. Warm air is going to be faster because the air molecules are warm, so they're trying to get away from one another. So it's going to move really fast, whereas with cool air, it's going to move a whole lot slower because the air particles are trying to get closer together to heat up. Ultraviolet radiation. Radiation of higher frequencies than visible light, which can cause sunburn and other types of damage. Ultraviolet radiation, some of you guys have heard it abbreviated as UV rays or UV radiation. Let's say during the summer months, I'm sure most of you have seen commercials for sunscreen, and it says it protects against UVA or UVB or UV rays or radiation. Well, this is what they're talking about. Ultraviolet radiation can cause sunburn, skin cancer, and damaged eyesight. That's another reason why people wear sunglasses, not just to be cool, but to protect their eyes from the sun and the radiation it produces. Infrared radiation, radiation of lower frequencies than visible light. It has less energy than visible light. Ozone. And ozone is the gas, it consists of a gas molecule that has 3 oxygen atoms. The ozone layer's job is to protect life on Earth by absorbing that harmful ultraviolet radiation that we just discussed from the sun. The ozone layer's job is not to protect us from oxygen or to provide us with oxygen. So you need to remember the difference. Ozone, it's to protect us from UV radiation or ultraviolet radiation. It's not to provide us with oxygen. That's not its job. It's to, again, protect us from ultraviolet radiation from the sun. An atom of chlorine can start a series of chemical reactions that break apart ozone, and it will not repair itself. The greenhouse effect. This was a vocabulary term a couple of weeks ago. The process by which certain gases in a planet's atmosphere absorb and emit infrared radiation, resulting in an increase in surface temperature. The greenhouse gases consist of carbon dioxide, methane, water vapor, nitrous oxide, and other gases that absorb and give off infrared radiation. And this is just a diagram to show and to illustrate the greenhouse effect. Air pollution. This is smoke and other harmful materials that are added to the air. So any kind of materials that are added to the air that's not supposed to be there is considered pollution. Particulates are tiny particles or droplets that are mixed in with air. Fossil fuels, these are fuels formed from the remains of prehistoric animals and plants. Examples include oil, gasoline, and coal. Smog is the combination of smoke and fog. Air pollution can cause health problems. U.S. Congress has passed laws to reduce air pollution. The Clean Air Act, which was passed back in 1970, limits the amount of air pollution that factories and power plants are allowed to release. It sets rules for making car exhaust cleaner. With the Clean Air Act and several other laws that have been enforced, what happens is if factories or companies don't abide by them, which means to follow them, then they can either be shut down by the government, or they could be fined a tremendous amount of money that they have to pay to the government for violating this law, or they could be fined and shut down. So it's very important for companies to follow the laws that have been set dealing with air pollution. Environmental Protection Agency, which the acronym for this agency is the EPA, is a government agency which measures the air pollution and works to enforce the laws passed by Congress. And some of you might can recall back a few years ago whenever there was the BP oil spill in the Gulf of Mexico. The EPA, the Environmental Protection Agency, were the ones that were called out to help clean up the mess. So some of you guys might be interested in going and working for this agency if you really like environmental things and learning about the environment. This might be an option for you whenever it comes time for you to choose a career. Human activities that increase greenhouse gases. Well, for carbon dioxide, power plants, cars, factories, and homes increase greenhouse gas of carbon dioxide. Cattle, livestock, bacteria, and landfills increase the greenhouse gas of methane. And nitrous oxide is increased with fertilizers and chemical factories. And these are just a few examples. This doesn't include everything. This is just a few examples. And scientists are developing ways to cool and heat buildings, transport people and goods, and make products using less energy. I'm sure some of you guys have heard about going green. It's really popular right now. That's where a lot of jobs are going, is to make clean energy for different products, and different companies are coming up with different goods and products to help better the environment.